So now it gives me great pleasure to start the first poster Blitz session. There are three poster Blitz sessions through the conference, one on every day, where you will see some of the posters. It's not all the posters. If you want to see all the posters, please go to IIASA Connect. You can see the link in the chat for IIASA Connect, where you can see all the posters. And also we have a poster competition where the audience can vote for their favorite poster. The voting is open until Friday, shortly after the third and final poster session. And the winner of the best or favorite poster competition will win a trip to come and visit IIASA. So I encourage everybody to vote for their favorite posters. And so the Poster Blitz session number 1 is moderated by Professor Li from the Institute of Geographic Science and Natural Resources Research at the Chinese Academy of Sciences. Can I pass the floor to Professor Li, please?
Okay, Ian. Hello, everyone. I'm Xiubin Li from the host institute on site, and welcome all of you to come to my institute to attend this important conference. We announced, Ian has said that introduced that we announced the call for poster abstracts in August and select 22 posters in total. All posters can be viewed on IIASA Connect, and for on-site participant, you also have this booklet. We printed the abstract of all these 22 posters on this booklet. And we for the next 3 days, we have 3 poster sessions. Due to the time limits, we select from these 22 posters, only 12 others to present on this conference. And the conference sets a poster award. So we invite all conference participants to vote for your favorite one, your favorite poster on IIASA Connect. Please vote. Everyone has 1 vote. So the poster award winner will be announced during the closing remarks on the 22nd. Okay, so the first poster session today, we have 4 posters to present, and each will be given 5 minutes to present. And following these 5 minutes, we have 2 or 3 minutes to discuss, question and answer. Okay, let's move to the first presenter, Mr. Li Jincheng, who is online, I think. Li Jincheng from University. Are you ready? Are you ready, Jincheng?
Yeah. Thank you very much.
Okay, please.
Yeah. Hello, everyone. My name is Jincheng Li. I'm a PhD student in Peking University. My research is effects of environmental protecting policies on nutrient export in the Yangtze River Basin. High-resolution sources data is pivotal for the simulation of nutrient production and flux in a watershed. This study constructed the China emission inventory of nutrient model based on county data. Using the Yangtze River Basin as a case, this study calculated the nutrient production and flux, analyzed the contribution of each sources, and evaluated the impact of environmental protecting policies on the nutrient flux. This is the research framework, which includes 3 parts. The first part is data sources. The second part is scene model, which is a China emission inventory of nutrients with 0.1 degree grade, which based on county level data. The third part is nutrient environmental progress, which includes nutrient loss function and parameters optimization. The map shows the mean water quality station and the mean hydro station on the mean stream of Yangtze River. The nutrient flux of these stations are the optimization objective. I optimized the loss functions parameters by GA algorithm. This is the nutrient production and components of 2,193 subbasins. We found that the central part and estuary are the hotspots of nutrient production. For the components of whole basin, cropland is the largest proportion. The percentage of point sources is very small. From the distribution of nutrient sources, we found that the central, eastern, and estuary are hotspots of nutrient flux. In the histogram, cropland budget is the largest, livestock second, and soil erosion couldn't be ignored. Soil erosion contributed more to total phosphorus than to total nitrogen. Especially for upstream, soil erosion is the largest nutrient sources. The first scenario is the same amount of fertilizer is replaced by increased recycled livestock manure. Hotspots not changed much compared to the absence of measures. But for the components of total nitrogen, its contribution was cut in half. There are two parallel conclusions. The contribution of diffuse sources to nitrogen production and flux is much higher than that of point sources. The source erosion and urban non-policies can't be ignored. For the whole basin, cropland-related environmental protecting policies are more effective in controlling nutrient pollution. This study was supported by the Young Scientist Summary Program at the International Institute for Applied Systems, balanced with financial support from the Chinese National Members Organization. I would like to acknowledge the insightful feedback and support provided by my supervisor, Dr. Tang and Dr. Chris, in Biodiversity and Natural Resource Program and IIASA. That's all. Thank you.
Okay, thank you, Jinteng. Any questions? So any questions online? Okay, if no question, we can move to the second one. The second presenter from Xiamen University, Yangfan Li. Yangfan is here, yeah, on site. Okay, okay, I'll give you a floor.
Okay, thank you. Thank you, IIASA and the Institute of Geography Sciences and the Natural Resources of CIS to provide a great platform to for us to exchange the systems analysis in Asia and in the world. I'm from Xiamen University, Coast City in China. And today my topic is coastal resilience, land, water, biodiversity, and access. This is abstract. Most of the abstract includes 3 sentences. First is governing. How can we have a good governance on the coastal urbanization and environment change? The second thing is a new resilience framework. What is a new framework for the governing? The third is how to use the framework into the integrated ocean and coastal management. This is first thing. What is a new framework? That is coastal resilience framework. It's land, water, biodiversity nexus is can be applied into the coastal urban land use, land cover change, environmental impact and early warning, coast spatial vulnerability, resilience, and ecological governance. This is the methodology of my research. Firstly, I will show you the key findings of my group, called UREC, Coastal Urbanization and Regional Ecological and Environment Change Resilience. We use the resilient thinking and the resilience practice in the coastal China, from Jiangsu Lianmingang city in Jiangsu province, Taihu Lake, to South China, Xiamen, Fujian, GBA Great Bay Area, Guangdong province, and Hainan province, Haikou city. From science to planning and practice, from the city, mega city, urban region to the coastal of China and the coastal Asia, maybe future the coastal world. All the work are based on the resilience and the systems analysis. Another key finding of our team research is coast vulnerability and resilience. We used the InVest model and assess the sea level rise background and what's the reclaimed and the natural habitats role in the coastal vulnerability status. We found that restoration and conservation of natural habitats can reduce the risk of mainland China's coast population exposure to natural hazards by as much as 45% by the end of the 21st century. Another key finding is ongoing work now, is unpublished data, is a social economic inequity and resilience. We use the special disparity of indicator of coastal resilience, including coast exposure, is an extreme sea level rise, a GDP per capita in low elevation coastal zones, and habitat role. We use the indicator and resilience methodology to find the lower resilience and the country concentrate in the north, east and south of coast China, and the human rights, group equity and corruption largely accounts for the differences in resilience. The last figure is the future potential collaboration based on system analysis in Asia. Firstly is land-sea integration, is a methodology oriented. We want to expand the coupled land-sea system dynamic model and find the system turning points. The second thing is a resilient coast cities and communications, is a mechanism oriented. We use the coast resilience index, just I mentioned, in the coast global assessment, equity resilience linkage, and disproportionate exposure. The third thing is integrated coastal management, is action, is a practice. We want to do the climate resilience hotspots and how to use the resilient thinking into the coastal spatial planning. Okay, conclusion. This poster, we presented an indicator-based system analysis includes the land, water, biodiversity nexus, and the land LWB nexus is in the coastal is key to understand the characteristics of system resilience under intensive human impacts. The last thing is the effective management of land reclamation, land-based pollution, conservation of habitats and biodiversity, land sea integration, and collaboration in the coast sea are critical in transiting towards regional sustainable pathways. I would like to express my thanks to National Natural Science Foundation of China, the NSFC's continuous funding and support us to do the systems analysis work from 10 years ago. And this funding is also the my co-supervised PhD students to get the NSFC and IIASA co-findings for the ocean fishing work, ocean fishing research work. And this is my contact. If you have any interest, you can find my website in Xiamen University State Key, Laboratory of Ocean Marine Environment Science. And you can also find my papers and publications in the ResearchGate website. Thank you so much.
Okay, thank you, Yang Fan. We have time for that one question. Question? On-site, both on-site and online. Any question? Okay, thank you, Yang Fan.
We can discuss later in the discussion part.
Okay,
Thank you so much.
Our next presenter is Ming Ren, who is also from Peking University. Ming Ren is also on site, I believe. Please.
Hello everyone, I'm Ming Ren from Peking University. I'm a IIASA PKU postdoctor, and my topic is decarbonizing China's iron and steel industry from the supply and demand side for carbon neutrality. This research explored possible low carbon transition pathways for China's iron and steel industry to achieve carbon neutrality by 2050. We get the following three main points. Although energy-saving technologies can reduce CO2 emissions in the short term, however, in the long term, adopting breakthrough technologies like CCS and hydrogen-based reduction, increasing the share of EAF, and decarbonizing upstream energy supply sectors will be crucial for climate change mitigation. And hydrogen-based direct reduction technology would be an effective option for CO2 emission reduction in scenarios where CCS is not available, with its share increasing to 23% by 2050. And system-wide cross-sector decarbonization can help achieve climate target at lower cost through flexible technology combinations and avoid carbon leakage into the upstream energy supply sectors. In this research, we establish and we use an integrated approach that combine CGE model and bottom-up technology model. In the right figure, we can see that use the CGE model, we can calculate the steel demand and feed this number to the technology model. We can optimize the technology evolution. And in this research, we set 6 scenarios based on the CCS availability sectors under the CO2 constraint and the steel demand and the share of EAF. For the this is the result for the steel demand, and we can see that under the BAU scenario, steel demand increased from about 800 million tons in 2050, peaks at 1,000 million tons in 2020, and then decrease to about 750 million tons in 2050. Under the carbon neutrality scenario, steel demand in the two above mentioned year will be lowered about 4% and 21% respectively. For the technology evolution, we can check in the right figure that with the lower production cost and substantially lower carbon intensive, and the share of EAF will be an the scrap-based EAF will be an attractive low carbon option. After 2030, as the energy saving technologies reaches their maximum potential, innovative technologies like hydrogen-based direct reduction and CCS will play an increasing essential role in further realizing the CO2 reduction target. The share of the steel from hydrogen-based direct reduction will increase to 23% to 25% in 2050. For the energy consumption, we noticed that replacing blast furnace with hydrogen-based direct reduction will not substantially reduce total energy consumption, which will even increase as a result of energy efficiency losses in the hydrogen production process. And the increasing share of hydrogen-based direct reduction will remarkably increase electricity consumption, which can be used for hydrogen production. And for the cost, we calculate the unit abatement cost of CO2 emission and the CO2 abatement cost per ton of steel. We can see that by 2030, the increasing share of scrap-based EAF will decrease CO2 emissions with lower cost compared to the BF-BOF pathway, resulting in the negative unit abatement cost and the CO2 abatement cost per ton of steel in the four scenarios. The unit carbon reduction cost in scenarios where CCS is unavailable are higher than in the scenarios with CCS are available. Based on the above results, we can get the three conclusions. First, a steel demand reduction on consumption side will reduce CO2 emission by about 20% in 2015. Measures on the demand side, like adjusting the economic structure, reducing economic output, and improving material efficiency, are critical for achieving the carbon neutrality target, which decision makers should pay attention to. Decarbonizing the iron and steel industry in conjunction with the energy supply will effectively reduce total CO2 emissions. This will effectively mitigate the leakage of CO2 emission between sectors and facilitate the flexible combination of technologies from different sectors, making it possible to achieve climate goals at a lower cost. And finally, the introduction of hydrogen-based direct reduction technology will not substantially reduce total energy consumption. On the contrary, energy consumption will even increase because of energy efficiency losses in the hydrogen production process.
Okay.
Yeah, okay, thank you.
Okay, thank you, Mingren. Yeah, I'm sorry that the time is too limited. We have to move to the last one. Mr. Mahadi Shatfer from Sharif University of Technology. So Mahadi, are you ready? Are you online?
Yeah, yeah, yeah.
Okay,
Do you have my voice? Can you hear me? Hello.
okay. Yeah.
Excuse me, do you have my voice here?
Yes, we can hear you.
Hello.
Go ahead.
Yeah, okay. So I just shared my screen here. I hope you can see my screen. I try to quickly review because apparently we have just a few minutes to go through the research conducted. Yeah, the research here is about the holistic approach. And this job is done together with my colleague. The model for modeling the COVID is about the country Thailand. The story starts from here. These enter into the country. We can think of the whole thing of some infected cases.
So no signal. So Mahadi, can you hear me?
I think we might have lost him, Professor Lee. I think the connection's gone. So I think we should we're going to have to move on, I think. If that's okay.
Yeah, he's back, I think.
Sorry, do you have my voice right now?
We can show your screen, your slides from here. Monica, can you do that? So Madi, can you try and talk us through the slides?
Yeah, sure. So do you have my voice? Can you hear me right now?
We can hear you.
Okay.
I'm sorry, Madi, I cannot hear you. I don't know about other people.
Okay. So maybe you can. So right now I can see my slide, right? So shall I continue?
I think the connection is not very good.
You can continue, آقای دکتر. You can
Okay.
continue. They are showing your slides. شما ادامه
Okay.
بده.
Right.
Yes, and if you will, I think I would recommend if
So
you
I
could
was
turn
saying
off.
that then part of the.
Sorry, if you could turn off your camera, we'll have a better connection with you.
Right. I was saying that like part of the society can be think as exposed, and then these exposed people are those that are connected with the infected case, with the infected people. So we can imagine that these exposed people turn into the infected, get the disease, and we're gonna show it by the term gamma. And then also part of the susceptible people, due to like obeying the social distancing rules, they can be safe and they can be on the safe zone. And we're gonna show it by the term alpha. Also, some of the susceptible people can be vaccinated. From the infected case, depends on the disease severity. Some of them may need to be quarantined. And then from the quarantine people, some people may need to be hospitalized. So from the quarantine and hospitalized guys, some of them might be recovered and some of them may die, unfortunately. So this is the whole system that we modeled. And regarding the mathematical formulation, we have a system of differential equations with many model parameters and also fractional orders. What we need to do is to match this system of differential equation with the actual data. So for that, we use the algorithm using a back analysis. So what we did in this back analysis is to generate a number of random realizations, random samples, and then also we compared them with the actual data. Those who fall in the close vicinity of the actual data, we just accepted them, and the rest were rejected. So from the accepted cases, then we choose the most optimal case. I'm not sure if you have my slides or not. Then with using this methodology, we can find the most optimal case, which is beautifully matched with the actual data. And this is actually the prediction of the system. That means we can go through the future and we can understand how many people infected, how many people recovered, and how many died. And then in the next step, we just went through the probabilistic part of the research, and we modeled the infected, recovered, and dead case in a probabilistic way. So we have some 3D graphs and some contour graphs. Then we can just choose a certain time in future, and also choose a certain amount of target probability or risk. For instance, let's say 20% of risk, and then having this ISO probability lines and also the certain time that we chose, we can understand what would be the number of cases infected. or what would be number of cases died or number of cases recovered. If this number of cases is matched with what we expect, then the disease status in the society is acceptable. If not, then we need to like maybe intensify to ask the people to wear the mask or intensify the social distancing rules or increase the vaccination or anything else that can help us to control the disease. This is just a whole research that I'm just trying to explain to you in a few like minutes. Yeah, thank you so much.
Okay.
Yeah, you can. Yeah.
Okay. Thank you, Mahadi. Thank you for your interesting presentation. So because the time limited, I'd like to close this session. And the last word is thank you very much for all the 4 presenters today. And because the time is limited, that for our participants, you can come to the IIASA Connect for the full information and communication addresses of these presenters. Thank you very much.
Now, the moderator for this Poster Bliss session number 2 is Dr. Ting Tang, who is a research scholar from the Water Security Research Group in the Biodiversity and Natural Resources Program at IIASA. Ting Tang, I would like to pass the floor to you. And you asked me in the chat about whether there's questions for the posters. I think in the interests of time, the poster presenters just have time to present their poster and then we move on to the next one. If you could do it that way, please. So over to you, Ting Tang.
Yes, thanks, Ian. Good morning, everyone. So we just start straight into the poster presentation. The first one will be by Hao Zhao. That's on the topic of China's future food demand and the implication for trade and environment. The floor is yours, Hao. I hope you are around.
Maybe he's in the auditorium.
That's what I assumed.
Yeah.
I don't see videos right now.
I don't see, do you see the auditorium?
I don't see the videos from them anymore.
No, nor do I. But they're there. They're connected. Okay, maybe there's a video.
He's not online, so I assume he's in the on site.
The videos come back.
So maybe they just come back now.
Yeah. Should we start again, do you think?
Yes, sure.
Okay, perfect. So welcome back everyone to the poster session number 2. Poster sessions. Sorry, this is a poster blitz session. It's for 4 of the selected posters, not all the posters. You can see all the posters in IIASA Connect, and you can also vote for your best poster on IIASA Connect. I'd like to pass the floor to Ting Tang, who's a research scholar in the Water Security Research Group at IIASA, and she will be moderating the poster session. Over to you, Ting Tang.
Thanks, Yuan. Welcome back for colleagues who are on site. So I will pass directly to the presentation of Hao Zhao on the topic China's future food demand and the implication for trade and environment. I think Peter Havlik just also briefly mentioned the topic, and Hao will go a bit more in detail on this. So the floor is yours, Hao.
Okay. Can you hear me now?
Yes, it works.
Ah, great. Okay, so, well, would like to introduce our work and just published in the Nature Sustainability recently and in collaboration with many IIASA colleagues. So here a little background is that satisfying China's food demand without destroying the environment is one of the greatest sustainability challenge for the coming decades. And here, if we want to assessing the impact of the future food demand, it requires a comprehensive analysis for the whole agriculture sector. And tracking the global environmental impact calls for the model presenting trade bilaterally. So here we employ this global model, and Peter just introduced a little before. It is a partial equilibrium model, and it's integrated many of the biophysical models like epic and ruminant. Based on this, we further developed the methodology to calculate virtual trade impacts like these equations. And then for the better representing for the China, we also improved the geographic information and the policy like the self-sufficient rate of the 95% of green consumption, and also the zero fertilizer resources use, growth in the resources use side. So this is the first result, and we can see that the increasing demand for the livestock products also drives the large feed crop demand increasing. And in terms of the production side, most of the increasing demand will be fulfilled by domestic production. However, we still can find some big gaps in the ruminant product, in dairy and ruminant meat, and also the oil crops are still maybe still fulfilled by the imports. And here we assess the changes of the future environmental impact of the China's future food demand, and we can find that the increase of the virtually imported agricultural land is higher than that bring from the domestic production. And in terms of the nitrogen and water uses, the virtual imported impacts are only account for 9% of the China total related consumption, because we import soybeans that does not need so much input. And we further investigate the environmental impacts on the different exporting countries. The left side is the China's major trade partners, and the right side is the China major imported commodities. And we can find the trading ruminant meat and oil crops lead to more environmental impact. And Brazil, Australia, and US are China's major virtual trade partners. And New Zealand turns out to be susceptible to China's import. Half of the agricultural land and almost 1/3 of the GHG emission is used for producing ruminant products for China. And we also have another two alternative scenarios. It's this RD and HD, which means the restricted development and high development scenario. And we also test these different scenario drivers, and we found that the distribution of the environmental impact varies based on the openness of trade. So the conclusion is that the trend of the China's growing food demand will rely more on imports, and in 2050 it will reach 18%. For now, it's only about 14%, and by 2030, twice as much more additional agricultural land will be imported to China from outside, and then what will be brought into it into production domestically. And this besides the policies implemented in China. And I think the appropriate trade agreement is also important. And you can find more information on this paper here. And we acknowledge the NSFC and also the FIBO Consortium and the YSSP program. Thank you.
Thanks, Hao. Very nice study. And I think for colleagues who want to know more, please refer to the paper on leisure sustainability. It's a very interesting topic for many of us as well. So the next presenter is, forgive me if my pronunciation is not very good, is Banwol Visvandra Raj Sen. So we didn't find him or her in the participation list. Could you please speak up if you are in and under another name? I guess that's a lot yet. So maybe we move to the next one. That's Yazhen Wu on the topic of global land use change and food security implication of China's bioenergy development under 2016 carbon neutrality targets. Another very relevant in terms of China's energy policy. So Yazhen, are you in? I saw her name. Yazhen Wu, please speak up. I see that you are in the chat. We also received a recording from her, so if she cannot speak right now, maybe we can just play the record.
Hello everyone, I'm Yazhen Wu from Peking University, and this poster is a brief summary of my YSSP study this year with the joint effort from PKU, IIASA, and also the CIS Center for Agricultural Resources Research. The topic is about global land use change and food security implication of bioenergy development under the carbon neutrality target. Here we take China as an example to analyze the impact of the increased bioenergy demand under the carbon neutrality scenario, and the portfolios will be the different impacts under different bioenergy import portfolios. And finally, how the potential trade-off could be mitigated by spatial and time optimization of bioenergy production. So to answer these questions, we were using the global modeling framework to quantify the possible impact of bioenergy development on agriculture and land use sector and hence on food security. Here are the scenarios. First, we have a baseline scenario without additional bioenergy demand, and then a domestic scenario where the bioenergy demand is to be corresponding with the RCP 1.9 climate change mitigation scenario, and the excess bioenergy demand compared with the reference scenario is assumed to be produced domestically. And then a series of stylized trade scenarios where we assume the excess biomass is to be produced and imported from different regions in the world. And finally, some optimization scenarios where the model is allowed to choose the best places for biomass plantation itself endogenously. So moving to the result, first, the land use change for bioenergy planting. We found that the scale of land conversion for biomass plantation would differ greatly under different kind of bioenergy production and import scenarios. And then the induced land use change for biomass plantation will cause the rises in food prices, and finally the induced increment in undernourishment rate. By 2030, this kind of negative impact will be around 1%. And also in several scenarios, we could observe some significant regional spillover impact on the hunger risk. Yeah, however, this kind of negative impact could be largely mitigated through special optimization of global biomass production. And at the same time, with stricter forest protection in place, the additional deforestation induced by bioenergy plantation will also be mostly eliminated, indicating that there are chances that we can better coordinate the different SDG targets under the carbon neutrality target. And finally, we also found that the possible negative impact on hunger risk will be more prevalent in near term, which means that we might need to find better time window for bioenergy to enter more into the energy system to better coordinate the target of carbon neutrality as well as food security. So here are the conclusions. First, the diversified food security impact could be expected under different bioenergy production and import portfolios. And at the same time, the importance of regional optimization and timing of bioenergy production should be taken into consideration when we are developing the bioenergy development strategy in the future. Finally, I want to express my sincere gratitude to the YSSP program, to IIASA and my YSSP supervisors and all the colleagues who have provided constructive help and advice to this study. So that's all. Thank you very much for listening, and you are welcome to contact me anytime. Thank you.
Great. That's the recording from Yazhen Wu, and I'm going to call the last poster again, just in case he is in again. That Ban Wu Singh, are you in again right now? We had a few more participants just in case he comes in now. Okay, then not yet. Then we go to the last poster on the topic from Yuchen Zhang. That's on the topic of adoption of rice auto sailing machinery that benefits Asian urban food security in multiple ways. So, Yuchen.
Yes, right here.
Yeah, Shipper, please go ahead.
Sure, yeah, thank you. Good afternoon, everyone. My name is Zhang Yuquan. I'm really pleased to have this great opportunity to present our research on modeling the food security effects of new technology adoption in peri-urban settings. This is a joint work by me and Dr. Marcaro, and also my colleagues and graduate assistant at SJTU. So the background of this study is that the smart mechanization of the agricultural sector may be an inevitable must for the future, because in the peri-urban areas, we are facing the issues of limited labor supply, high wage rates, and prohibitive land opportunity costs. And against the backdrop of rapid urbanization in Asia, the rising bar to perform peri-urban agricultural activities may actually present threats to urban dwellers' food security. And so this study takes Shanghai, a very densely populated metropolitan area housing over 24 million residents in East China as a case study to investigate the potential of a new technology that auto-mechanizes the seed planting for rice production. We used the newly developed agricultural sector model, Shanghai agricultural sector model, to explore the effects of the technology diffusion and the policies regarding the adoption technologies. And specifically, this regional model represents the agricultural activities in an economic welfare optimization framework. And it tries to simulate the decision-making of farmers regarding their land use allocation between crops. And the scenarios for this study include two major dimensions. The first dimension involves the adoption levels in terms of rice acreage covered, ranges from 10% to over to 100% in 10% increments. And the second dimension is about how we are dealing with the exogenous price cases versus the endogenously generated price cases. So these two open status and the free, this is the closed and open status of the agricultural sector were considered. And here, let's take a look at the results. I would like you to pay attention to the panel C, in this figure 1. So basically this shows how the adoption of this new technology spreads from the inner suburban districts to eventually more remote islands across Shanghai as the adoption level rises. And then for figure 2, we are showing that the rice production levels associated with the adoption would certainly get increased. And meanwhile, the labor resources devoted to rice production would decrease correspondingly. The panel C and panel D shows that the chemical fertilizers usage would increase. However, the increase is not necessarily the case for pesticide usage. Now let's move on to figure 3. And in panel B, I'm showing that as the adoption level rises, we can see that there will be expansions of acreages for fruit, cabbage, Solanaceae, and also cucurbit. So this would lead to a situation that where we are going to see that in addition to rice production increases, there shall be increases in production levels for different kinds of vegetables and fruits. And what's more interesting, I think that the introduction of this new technology would also induce reallocation of labor resources toward different kinds of enterprises, including some of the major vegetables that we consume on a daily basis. And then let's take a look at the panel C and D. This shows the crop-specific fertilizer usage increase or decreases, as well as the pesticide use. We can see that on balance, the fertilizers usage would increase, whereas that for pesticide use, we would only expect very slight changes. And for panel E, this shows that the price level on aggregate basis would also increase, even under the fixed price scenarios. So that's for the results, and for the conclusion that I would like to mention about 3 major points. The first point is that the regional crop mix patterns would certainly be modulated because of this new technology adoption. And the second point is that in addition to seeing rice production increases, that because of this, the reallocation of labor resources, there shall be increases in vegetables and fruits as well. And this will help to the urban dwellers to increase their variety of choices. The third point is that while we expect a rise in the physical outputs and the diversity of local produce, overall that greater amounts of chemical fertilizers will be involved. So there shall be some trade-off. And so that's our presentation. Thank you so much for your time.
Many thanks, Yu Chuanzhang. And this is a case where it's at a much smaller scale compared with the first 2, but it's also very interesting in terms of the technological advance or a new machinery use. So finally, thanks a lot. And finally, we have Bobo come on board in the room meeting. So could you please try to speak, and so that we know that you are in and it works. Banwa? Maybe my pronunciation is not correct.
Yeah.
Okay, it works. Great. Just let me introduce your work first, and then.
Yeah.
Welcome, Banwa. And he will be talking shortly about to achieve sustainability through biodiversity conservation with a case study of Ransenberg Tiger Reserve. You will pronounce it much better than me, I guess. I am sure. So please go ahead, floor is yours.
Can I share my presentations?
Yes, of course. Please go ahead.
Is it visible?
Yes.
Okay. So first of all, thank you so much for giving me opportunity to share to my research in the particular of Ranthambore Tiger Reserve, which is located in the Rajasthan state.
Sorry, just a second. Are you with your presentation on? Because right now we see the web page.
Sorry. What about you asking?
Right now we see the web page of
web page. Okay.
no, a PDF file, I think. Is that
Yes,
what
yes.
you want to show?
This is PDF file.
Ah, okay, super. Please go ahead.
Okay, no problem. Thank you so much. So myself, Bhamar Vishwendra Raj Singh Ranawat, as an assistant professor in Department of Geography, Faculty of Earth Sciences, Mohanlal Sukhadia, University of Udaipur, India. My research is especially based on the Ranthambore tiger reserves, which is particularly located in Rajasthan state, especially in Western India. And this is a best tiger top sighting in the world. And we know around 70% of tiger populations are living in particular our country, especially. And this is a hotspot of like a central tiger landscape complex. So this is my first topic to achieve a sustainability through biodiversity conservation, a particular case study of Ranthambore tiger reserves. So how sustainability come through biodiversity conservation and particular species of tigers. So this is my abstracts. Forests are habitat for every plant and animal on the planet because it provides a sustainable environment for them. Forest has a different type of plant that are used for living in the forest, and millions of people live in forest, all of them including living outside of the forest and depend on products. We get that forest for their livelihood, and forests are home 80% of the world global biodiversity. We know anthropogenic activity are continuously diminishing of flora and fauna since the starting of human society. At that time, humans are relied on environmental resources fulfillment of their basic needs by doing hunting and gathering activity from primitive society. But in the contemporary world, the time is a little changed and the relation between man and environment has totally changed. The development of forest ecosystem is just seen as within the context of maximization of human needs at the value of natural reservation of the forest habitat. Man-made activity are the major responsible forest factors for the deterioration of the forest ecosystem. The prime objective of the research study is to assess the change in forest habitat over the time and impact of anthropogenic activity in the core as well as buffer area in Ranthambore Tiger Reserve. The study has used a digital remote sensing like Landsat 2, MSS 1975, Landsat A, OL, TIRS 2020, and GIS technique to monitor changes in core and buffer area of Ranthambore. Landsat data covers a period of 40 years are used for change detection studies, and digital elevation model and land use and lake cover, relief, aspect, drainage pattern were calculated for change detection and normalized differential vegetation index by using GIS for core and buffer area respectively. Populations like a demography data were taken for the census in 1991, 2001, 2011, because in our country, especially after every 10 years, we will conduct like a census specialist and change detections result study area showing the forest area change over the time and land use and land cover changes. The result are presenting the diminishing of forest areas and direct interlink with surrounding people, because this particular area is located by like tribal populations and which is more dependent on the forest ecosystem like a forest products specialist. And human-wildlife conflict frequently data showing the anthropogenic impact over the forest and also hotspots of human-wildlife conflicts. Because, this area is continuously shrinking, and as well as wildlife numbers of population. Wildlife populations is continuously increasing. The area is completely like a shortage and very shrink. So that's why wild animal come from core area to buffer area and entered in human habitats and counter with man's, especially human activities. So that time its chance of conflict is happening. And this is my methodology, especially the study is a mixture GIS and remote sensing technology to detect spatio-temporal dynamic changes of Ranthambore tiger area, forest area. The study used remote sensing data from 1975 to 2020. The image processing task applied using ADAS imaging software, ArcGIS, both primary and secondary data were employed during the research, and each data has been found to be relevant and important within the research process. And primary data employed within the study were Landsat, MSS data, image acquisitions, 1975 with four bands and Landsat data image acquisitions date of 2020 and Amsterdam 30-meter resolutions. So this is a source of like a geospatial data, as well as images were classified in LULC classes: the dense forest, scrub forest, grassland, fallow land, and water bodies. Dense forest area covered by dense forest with high pixels, open forest as bushes, low pixels as greenness, agriculture of grassland, inactive unseeded land, riverbank, low fertile area, barren lands, and water body, every pixel which contains water like a river, lake, stream, and pond. And this is chart of data set of methodology. First is remote sensing data, geographical information system data, human wildlife conflict, which has been collected from the Ranthambore Tiger Reserve official government office. And in this particular data, two type data have been collected. So range-wise human wildlife conflict, because the area is completely distributed in the different like a range. Range means like a zones. So in this particular Ranthambore area, around 12 zones. So what zone is divided in core area as well as buffer area. And second was the range-wise human wildlife conflict, particular in like a, because this area is completely lie in the two districts. First is Savai Madhopur district and second is the Karoli district. So both districts as a
Excuse me, could you try to speed up a little? We are a bit running late.
Okay.
Thanks.
Yeah, thank you. So
1 minute left.
Okay. So the Savai Madhopur district and Karoli divisions both comprises at Ranthambore Tiger Reserve. So that's both data is comprised and finally calculated a hotspot analysis, and demographic information comes from 1990 census, one census, 91, 2001 and 2011. So this is like a actually informations of like a methodology. And this is my study area maps. So you can see this is like a geographical informations of my study area. So the in core area especially is a dark green, showing like a first one is a Ranthambore National Park and second one is a Kaila Devi Wildlife Sanctuary. But both comprises, so we can say Ranthambore Tiger Reserve species. And one perennial river is as a flowing towards northeast directions, which is the name of Chambal River, and another tributary of like a Banas River. And this river is a phiotic role playing in the immigrations of like a tiger species. Sometimes tigers come from core area to buffer area through river channels, river channels. So some that is conflict chances that time increases. And this is information of like you can see this is a drainage pattern. So particularly this is a measured streams and stream orders. We can say stream order first, second, third, fourth, fifth, total fifth orders in this the drainage pattern. See, and another one is a digital elevation models, because these core areas highest like a altitude areas, and a surrounding area is like a down area specialist according to sea level. And this is information, land use and land cover information. So first information is especially particularly core area. First
Perhaps you could directly go to your conclusions now, because you are already running a bit late. Thanks.
Okay.
Thanks.
Thank you. So this is a map of a core area and buffer area. And this is a statistic of land use and land cover in core buffer area 1975 and 2020. And this is, human wildlife conflict, which places is more conflict happened. So this is, you can see more like a area is concentrated in like a bank of Savai Madhopur National Park. And this is like a, sustainable management practices. So you can see tiger safari, rural tourism, alligator wildlife sanctuary, religious tourism. And this is sustainable relation with the nature, human and culture. And another UNESCO heritage site, Cantoff and mosque and pilgrim activities. So this is like a sustainable practices as well as challenges too also. So now I'm focusing on the conclusion. So the result is shown. The paper has been to primary assessment of time series data analysis, extensive fieldwork and surveys need to conduct to verify the results and refine the analysis more accurately. Climate data set, precipitation, temperature, soil are also can advance analysis and more descriptive results. The forest ecosystem Ranthambore Tiger is directly linked with anthropogenic activity. Over it observed the high dense forest in buffer area, conserve and increasing with high reforestation over the area. Forest density terms and NDVI evidence from the series Landsat data image have increase in the buffer area shown positively throughout the zone of analysis, and there is a little bit decline in the core area, but it only have some around 2 kilometers, only 2 kilometers. Last 40 years, land use land cover analysis shows that dense forests and shrubland areas again increasing, and agriculture and related activity are expanding near the buffer area boundary and areas of tiger reserve, but still is very little. The population increasing rapidly, resources are a limit, so anthropogenic pressure is a negative impact on buffer area of tiger reserve, and buffer area of northern Taparta have a high anthropogenic pressure, which is directly correlated with population density. And for the sustainable development of forest ecosystem, an holistic approach should be applied, and bottom-up approach in periphery areas also used for rural development, which will help to reduce population pressure on ecosystem. Eco-friendly technique of agriculture, awareness, employment generations like entrepreneurship in rural areas should be promoted, so population pressure will be reduced, and man-environment relationships are also changing with technology upgradation. People of surrounding area not dependent on the forest direct ecosystem services like fuel and fodder, which is a positive result for forest. And thank you for giving me opportunity, and especially acknowledge my late Professor Abhi Singh and Professor Anjan Singh and Mr. Ravi Misra. So both all people and to support in this particular research people. Thank you so much for giving me a golden opportunity to share my research. Thank you, Professor Ting Tan.
Thank you. Thanks. So, for the interest of time, so I give back the floor back to Yun now.
Please, can we move to the first poster presenter? This is Wenzhong Meng, who has a poster on environmental and health benefits of clean heating plan in northern China. Wenzhong, are you online or are you in the auditorium?
Yes, I'm online.
Okay, perfect. Over to you, Wenzhong.
Thank you. Okay, thank you. Good morning and good afternoon to everyone. I'm Meng Wenjun from Peking University. Our study is focused on the clean heating plant in the northern China and its environmental and health benefits. The solid fuel used for heating is still one of the major contributors to severe air pollution in North China. To address this issue, a campaign was launched in 2017 to substitute coal with electricity or pipeline-based natural gas for heating. However, due to the accessibility and affordability, some prefectures could not afford the full implementation. Based on the social economic factors, a differential penetration rates needs to be addressed. Here is the main modeling framework of this study. We first established the emission inventory, and then the Wolfram model was used to simulate the ambient particulate matter concentration. And for indoor air quality, we combined an indoor air quality database and the infiltration from outdoor concentration. And then based on the time activity patterns, we got the exposure and then calculate the premature mortality for mitigation benefits assessment. And the campaign was divided into two regions. One is focusing on Beijing, Tianjin, and 26 other prefectures in the surrounding area, which is called R28 in this study. And the rest was referred as R128, containing the rest 128 prefectures. For the rural areas, the clean heating rate for the two regions in 2021 was set as 60% and 40% respectively. The plan showed a great reduction on emissions and concentrations. Here shows the population-weighted exposure and contributions for the R28 region in before and after the clean heating campaign. Because people usually spend most of their time indoors, the exposure and health benefits would mostly come from severe indoor air quality. The population-weighted exposure would drop more than 40% after the campaign. And among that, more than 90% reduction came from indoor residential sectors. Based on the progress in the R28 region, the influencing factors of the penetration rates, such as terrain slope, population density, and per capita disposable income, were quantified to develop an intervention scheme with differentiated targets for the rest R128 region. As is shown in the map, it has some similarity with the residential emission distribution in the same region. And here shows the spatial distribution of air particulate matter, of ambient particulate matter concentration and premature death difference between the differential and fixed penetration rate in 2021. It evidenced that a differentiated scheme would achieve more environment and health benefits, especially in the northeast eastern plain and Jiaodong Peninsula, where it has more dense population and higher income. To briefly conclude, the clean heating plan for northern China effectively reduced the severe air pollution in winter, while the substitution campaign was launched to solve ambient air pollution problem, but it came out that the more benefits would come from its impacts on indoor air pollution. And the progress of the substitution varied among municipalities and was mainly influenced by some socio-economic factors such as population density, terrain slope, and income. And finally, the differentiated clean heating targets, even though it has the same population substitution, but it can bring greater environment and health benefits. And here are the acknowledgements. And if you have interest or any questions, please feel free to contact me. And I'm welcome to any questions. Thank you.
Thank you very much, Wengjung, for your presentation. That's great. So I'm pleased to say that Professor Hooman Mohammed is back now online. So I pass the chair back to you, Hooman, please.
Yeah, thank you very much, and sorry for the inconvenience made. Well, the next poster would be from University of Peking, and Xiaoyu Liu will make a presentation on the impact of carbon reduction to the consumption of water in China related to industrial facilities, which is a very critical issue with regards to the environment and its relations to industry and growth of the economy. So I would like to invite Xiaoyu to make a presentation.
Okay, thank you, Hooman. I'm starting sharing my screen. Oh, sorry. Hello, everyone. My name is Xiaoyu, a PhD student from Peking University of China. I'm glad to present my poster titled Carbon Neutrality Turns the World Resource Red Line Greener in China. In this study, we uncover how achieving the carbon neutrality will benefit or threaten industrial world saving in 31 provinces. The results show that co-benefits exist for most sectors and provinces. Trade-offs and worse-offs will cause water use to rise, partially or even wholly offsetting water savings in some provinces. So there is a need for integrated water energy management to maximize the co-benefits and minimize the trade-offs and worse-offs. Basically, the CGE model is used to simulate the carbon emission and macroeconomy from 2017 to 2060. And the industrial water use is simulated exogenously while multiplying the water use intensity by output or power generation, where the water intensity is projected by the combination of the inventory and the water intensity target from the 3 red line policy. The output and power generation are from the CGE. Moreover, we designed the two scenarios and assess the effects of carbon neutrality. Okay, that's the results. First, the carbon emission changes. The national emissions and carbon intensity will both decreases by 71%, mainly from the energy-related industry and the tertiary industry. At the regional scale, power generation is the main contributor of the carbon reduction in the eastern and the northern region. By contrast, due to less thermal power in the central and the southwest region, the tertiary industries instead of the power sector are mainly responsible for the carbon reduction. Next, the output changes. At the national level, the outputs of every sector are projected to decreases, and the energy-intensive industry tends to suffer more, like petrol, oil, and power generation. Similarly, the provinces with high carbon energy and the industry structure will lose more output if they kept unchanged. So they are suggested to adapt the carbon neutrality in advance while developing the low carbon industry, like electronics and machinery. And due to the change of industry structure, the national industrial water use would decrease by 24%. Moreover, the co-benefit effects vary across provinces. In southern region, power generation contributes 65% of water saving due to the phase out of the fossil-fired power plants and the water efficiency cooling technology. By contrast, in the western region, water intensity sector, except for the power generation, are responsible for their total water saving. It's mainly due to the high proportion of clean energy there. In addition, increased water use by trade-offs and wash-offs will partly or even wholly offset the water savings, which creates risks for the local water stress in the especially in the water scarce regions like Beijing and Hebei. Furthermore, we compared the industrial water use with the target from the 3 red lines policy. We found that achieving carbon neutrality in 2060 could achieve the national and 12 provinces target of total industrial water use. We suggest for these provinces to promote the co-benefits to better water resource allocation. For example, the saved water can be returned to the natural water bodies for ecological purpose. On the other hand, the co-benefit effects are not sufficient for the target achievement in some provinces. Hence, imposing restrictions on the total water use is extremely necessary, especially for water scarce provinces like Shanxi and Gansu. And next, the conclusions. First, energy-intensive industries and provinces relying heavily on these industries are responsible for the major carbon reduction and will suffer the most output loss. Second, achieving carbon neutrality will bring significant opportunities and local risks for industrial water use. Moreover, there are some outlooks for water resource planning, including necessary restrictions for the total water use and stricter national industrial water use target in 2060. Finally, really appreciate for the support and funding. If you have any question, please contact me. And thanks for listening.
Yeah, thank you very much. That was Xiao Liu from Peking University covering topics and the links between water consumption and reduction of carbon. Okay, and this brings us to the 11th presentation. I'm not sure that Dr. Masul is present here, or shall we switch to the poster 12?
I think so, yes.
Okay, okay then. So the next poster is from the School of Economics and Management of Beijing University and is presented by Dr. Xiaohui Zhang. The title is Modeling Pathways to Low and Zero CO2 Emissions in China's Iron and Steel Industry and their impacts on the resources and energy. I would like to invite Dr. Zhang to make his presentation.
Thank you. Hello, everyone. Here is Xiaohui Zhang. And today I would like to share my latest study regarding whether the Chinese industry can achieving low carbon or zero carbon emissions in the future before end of this century. Why we do this work? Because actually we announced the 1.5 degree scenario to avoid the climate risk. At the same time, this year, many countries announced their zero emission by the mid of century or the around 2060. Actually, in China, the government also mentioned that we want to achieve zero carbon emission before by 2060. So that's why, under this background, I would like to show you where the current steel industry are and whether it's possible to achieving zero or deep low carbon emissions in China. The first reason is that currently the steel industry accounts for over 1/4 of total CO2 emissions in China because it produces over 60% of steel products across the world. And at the same time, it still emits a lot of air pollutants. Another issue is that the steel industry not related to the energy consumption also support many infrastructure buildings, also including the transportation and buildings. So that's why I would like to know if there have many sectors involved that to zero campaign, whether the steel industry can include it there. So that's why here we develop a model, a process-based integrated assessment model to analyze the future scenarios and possibility to achieving zero or low carbon emissions in China. And at the same time, we not only considering the current best available technologies and the current leaders in the steel industry, we also considering the future new technologies like the direct ore technology by using hydrogen, coal, gas, and plus CCUS. So another key highlight here is that when we forecasting the future steel demand, we considering the future new buildings and future new transport vehicles as well as the dome appliance. So that's why you see the table. We develop different scenario based on different steel demand, the high steel demand as well as the low steel demand. We also considering different process technologies to explore the future possibility regarding the emissions, the material consumption, and the energy consumption. So this model is developed based on IIASA's open source methodology framework, and we assume that the emission factor, like the electricity, are consistent with the 1.5 degree that are obtained from the Gaines model. Indeed, if we look at the result, especially for the up figure, we found there have many possibilities to achieving the zero or even low carbon CO2 emissions. Around 5 or more than 6 scenarios can achieving such pathway. But if we look at the process, there also have large difference. For example, we can using the electric based steel technology to achieving such way, but there will still have some emissions. But at the same time, we also need to some CCUS technology. And indeed, if we also look at the energy consumption, we can find and the cooperation between the CO2 emission pathway and the energy pathway. If there have, for example, like DRI-based technology used to achieving the zero emissions, there will have highest energy consumption. But if we select the electricity-based pathway, there will middle electricity consumption. At the same time, there will increasing the pressure for the power system. So how can we select this part? Another issue is that if we look at the material consumption, like the iron ore or the scrap, it means that, for example, the green pathway will 4 or 3 times higher than the 2030. It depends on whether we still have enough scrap availability, not only in China, maybe the beyond of China. And at the same time, if we look at the process energy consumption, we can find there still have some coal, but not so large, maybe less than 5 or 10%. But there have some special steel products. We need some current road to produce some special steel products because the scrap cannot produce the high special products, maybe for the airplane or for some areas. And the conclusion here is that indeed, based on this analysis, we found there have multiple possibilities to achieving the zero emission pathway before end of the century. But if we only look at the middle of the century, there still have around 20 or 30 million tons of CO2 emissions. It means that for maybe the land use can observe some CO2 emissions, and at the same time, if we only look at the steel industry, there still have some problem. For example, whether there have enough scrap to support the electric-based steel making, or if there have some enough iron ore as a resource to support the future steel production. And another issue is that if we move to the electric-based steel making, the electricity consumption would increasing so fast compared to the current sectors or compared to the other scenarios. This will bring some challenges, maybe the challenges for the power system, whether the power system can heavily generate the electricity by renewable or by nuclear or the hydro. And the future I will focusing on, based on this kind of pathway, which one is the most efficient and the most economical available to achieving in the future. And another issue is thank you for the NSFC and the career founder as well as the technical in China. Here is my contact. If someone interested for this kind of topic, please contact me. Yeah, thank you.
Thank you very much for your fascinating presentation. As highlighted by our presentators, modeling complex and complicated systems and their interconnectedness would be of great significance in a risk-informed development and decision-making, which is very critical at this moment.